In 1950, physicist Enrico Fermi and his colleagues at Los Alamos National Laboratory were discussing extraterrestrial life and the size of our universe when Fermi famously asked, "Where is everybody?" He wondered why, given all of the Earth-like planets capable of supporting life and the unthinkable timescales of the universe, there remains no clear evidence of alien civilization. Our galaxy, the Milky Way, is already so vast that the question of extraterrestrial life appears more a matter of where than if. Even within our own solar system, we've hardly managed to rule out the possibility of life on our nearest 3 planets. Speculation about basic biology taking place on or beneath the surface of our next-door neighbors remains alive and well, and that's still without getting into Jupiter's and Saturn's staggering nearly 100 moons apiece. The sheer distance from galaxy to galaxy is so large that it leaves the possibility of life elsewhere feeling all but inevitable. When we begin processing the size of the universe as a whole, the notion that the conditions were only right on this piddly blue planet begins to appear quite foolish. Of course, life exists elsewhere, even if it's the rare needle in a cosmic cliff that reaches entire light years tall. A factor that's often forgotten when we consider the search for life isn't only the enormity of space, but the enormity of time. It isn't merely a matter of discovering another civilization, but discovering it in that short period of time in which it's discoverable. Taking into account the dismal sort of fates that can befall planets, it's no given that life on even our immediate planetary neighbors would leave any remnants of its time spent there. The answer to whether flourishing and intelligent societies once lived on Venus or Mars may now be simply lost to the sands of time. Rogue asteroids may have rendered once teeming cities into gaseous wastelands in one fell cataclysm. For all we know, Neanderthals may have still walked the Earth when Mercurians first learned to harness the sun's power. Maybe it was one of the final developments their civilizations made before they went intergalactic or turned inward on themselves with a more and more powerful array of weapons. It's hard for people to process time on the scale that it exists. Even the lives of our immediate ancestors can be something difficult for us to fathom. Grappling with the amount of time between the emergence of single-cellular life and dinosaurs is more than most of us will ever be able to muster. Even the short time in which humans have walked the Earth is larger than we can truly appreciate. When we remember just how brief it is on the cosmic calendar that we've had tools like telescopes, rockets, and computers at our disposal, the question of why we haven't yet made unequivocal contact with another world begins to make more sense. It isn't only a matter of finding a speck in a field that spans possible infinities, but finding that speck in that short time before it turns to stardust. It's a common sentiment that civilizations can only advance to a certain point before destroying themselves. The timetable in which societies can make sounds loud enough for even their immediate neighbors to hear them is likely only a celestial blip. Another interesting explanation for Fermi's paradox is the idea of the dark forest. The hypothesis suggests that the universe is like a dark forest, where civilizations remain silent and hidden to avoid detection by potentially hostile others. Like a hunter alone in the woods at night, they assume that revealing their location could lead to annihilation by more advanced alien life. Inversely, if we'd entered close range of one another, one of us would have fired their weapon by now to assuage any doubts they had of the other's intentions. In our uncertainty, one of us would close the door to any of the good that might arise from interplanetary companionship. Another theory, the zoo hypothesis, suggests that aliens may have known about us for ages, but decided for a multitude of possible reasons that it was astute not to reveal themselves, observing us from a safe distance, like spectators at a zoo. The Great Filter theory suggests that while single-cellular life may be common, what's incredibly rare is for it to evolve to a degree of intelligence tantamount to our own. From technological challenges to the utter vastness of space and time, to concerted decision-making, there are any number of explanations for why we haven't yet had any definitive contact with extraterrestrial others. But Fermi's question reminds us that we're not alone. It offers no answers about where exactly other ecosystems in space might occur, only the certainty that life must exist somewhere. Within our singular galaxy, it's unlikely that we're the only creatures to have ever lived. Within the expanse of space, It can only be fathomed how many times life must have started, evolved, flourished, and disintegrated. The notion that Earth is completely unique in its experience in this universe is a near impossibility. In a time when rockets are being launched into orbit faster than ever before, and headlines about the possibility of extraterrestrial life are emerging left and right, it often feels like it's only a matter of time before we make our first unambiguous discovery of biological evolution beyond our planet. But while Fermi's paradox reminds us that even though communion with another world may be on our horizons, it's important to temper our expectations. It takes light 93 billion years to traverse the known universe. Throughout the stars, life could be copious, but we lack the ability to reach even our home sun without vaporizing. The furthest reaches of our own solar system are still well beyond us. We could spend the next 3 centuries sending radio signals to prospective civilizations and amount to less than a whisper in a churning ocean. Fermi's paradox reminds us not only to appreciate the incredible likelihood that life beyond our planet exists, but the awe-inspiring extent of our smallness. It's a simultaneous cause for hope and for the deepest humility. It gives us a reason to be excited for an interesting future on the horizon, but also a reason to revel in our insignificance. Thank you so much for watching. See you soon again in the next video. Until then, remember to smile, because you are someone very beautiful in this universe.